We are going to start now the next lecture of chapter 7 class 10 mathematics coordinate geometry. In this lecture we will talk about the area of a triangle. So if the coordinates of the triangle they are given to us, suppose the coordinates are a, b, c and the values are x1, y1, x2, y2 and x3, y3, then we are saying the formula for the area of this triangle will be 1 by 2 times these values. It is x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So how we are calculating these areas? It is shown over here. We are saying suppose these are the points A, B and C we are talking about. We have drawn the perpendiculars from these points. This is A, L, B, M and C, N. Now what is this length BL? That will be equal to x1 minus x2, and this length NL will be x3 minus x1. Now if we talk about the area of this triangle, so we are saying, look at this figure over here, it is ABML. We are saying in this figure both these lines, these are parallel to each other. So this figure, this represents a trapezium. Similarly, if we are talking about this figure over here, the second we are talking about, it is the first we are talking about is BMLA, second we are talking about is ALNC. This figure we are saying this is also a trapezium. These two sides, these are parallel to each other. And third we are talking about this portion over here, it is BCNM. This is also a trapezium. We are talking about these three trapeziums. So if we add the area of ABML to the area of ALNC, if we add both these areas and we subtract from this area, we are talking about BMNC, we have subtracted this area. So what we will be left with is the area of this triangle. And the formula for the area of the trapezium, we know it is half sum of the two parallel sides into height. So height for this trapezium, it is x1 minus x2. Height for this trapezium, it is x3 minus, we are talking about this, it is x3 minus x2. Now we are talking about the sum of the two parallel sides. So sum of the two parallel sides means when I am talking about this point B, the height over here it is y2. When I am talking about this point A, the height over here it is y1. So the formula we have for the first trapezium, this trapezium I am talking about, BMLA. So for this trapezium, the formula for the area will be half sum of the two parallel sides into height. So sum of the two parallel side means when I am talking about AL, this length AL I am saying, this value we have, it is y1. When I am talking about this BM means I am talking about this portion, the value it is y2. Next I am talking about is AL, ML basically we are saying it is the height of this trapezium, and the value of this ML we have seen it is x1 minus x2, and it is written over here. Similarly, for the second trapezium, I am talking about this whole trapezium over here. This is the first trapezium, this is the second trapezium. The answer for the area we will get in this form. And for this lower part I am talking about BCMD, the area of this trapezium will be sum of the parallel side. Sum of the parallel side means this side it is y2, this side it is y3. So it is y2 plus y3, and the distance between these two, it is the total distance we are talking about. This point it is x3, this point it is x2. So the distance between these two will be x3 minus x2. This is the value we are using over here. And on solving these values, we have taken 1 by 2 common from all these terms, and by solving these values we are saying the final answer that we will have it is 1 by 2 x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. And as the answer can never be negative, so we are putting this symbol over here. This symbol I am talking about. These are the two straight lines basically we are drawing, and we are writing the formula over here. This is the symbol for the modulus, or you can say it is mod. Mod is basically we are saying that the area can never be negative. So whatever answer we are getting, we will write only the positive value, and that will be the area of that triangle. Now next we have is condition for collinearity of 3 points. Earlier also we have studied the condition. We are saying if 3 points A, B, C are given to us, what we have to do, we have to calculate the distance AB, we have to calculate the distance BC, and we have to calculate the distance AC. If AB plus BC is equal to AC, then we are saying that 3 points they are collinear. The next thing that we can do is we can find, if suppose we are saying 3 points A, B, C they are given to us. If these 3 points these are not collinear, then they will form a triangle. We are saying if 3 points they are not collinear, then they will form a triangle. If we calculate the area of this triangle, we will get some value. It means if any 3 points are given to us and we calculate the area using these 3 points, and the area of we obtain the final answer it is 0, then these 3 points will be collinear. It means that we will have a triangle whose area is 0, means it is a straight line. So if we put these values in this formula, we will get that the area should be equal to 0. This thing is basically that the area of triangle ABC should be equal to 0. So this is the condition for collinearity of 3 points. Next we have the questions based upon these formulas. So first question we have is, we have to find the area of the triangle ABC whose vertices A, B and C they are given. These are the 3 vertices of the triangle. So we just have to substitute these values in the formula of the area. The formula for the area it is half. This symbol we are saying, this is mod over here. This symbol we are saying it is mod, or it is called absolute value. And this is basically we are saying we are considering only the positive value. We are not taking the negative value. Up to this point you can consider it like this. In your next classes you will study these kind of functions in detail. Now the values we have, it is x1, y1. These values it is x2, y2, and the c it is x3, y3. So substituting all these values in this formula, we have substituted these values in this formula, and the answer we have obtained it is over here it is minus 57. Because of the mod function, we are saying the negative sign is removed, and the final answer we will get it is 57 by 2. We are considering now the positive value over here, and the answer is 28.5. This is area. So the units we have it is square units. So these are the 3 points that we have. We have substituted these values in this formula. We have simplified the values and we have obtained the answer for the area of the triangle. Next is find the values of K so that the area of triangle is 24 square units. So again we are saying these are the values given to us, that x1 is equal to 1, y1 is equal to minus 1, x2 is equal to 4, y2 is equal to x2 is minus 4, y2 is equal to 2k, x3 is equal to minus k, and y2 is equal to minus 5, and the value for the area is given to be 24. The formula for the area of triangle we have, this is the formula for the area of the triangle. In place of x1, y1, x2, y2, x3, y3, we have substituted this value, and on solving this we will get that this will give us a quadratic equation, that is 1 by 2 into 2k square plus 3k plus 21. This is the area, and this should be equal to 24 because it is given that the area of this triangle it is 24. So we are saying the equation we get it is 2k square plus 3k plus 21, that is equal to 48. Now we have to solve this equation. So we can write it in the form 2k square plus 3k minus 27, that is equal to 0. So to solve this equation, we can just write k is equal to, it is minus b plus minus square root of b square minus 4ac. It is minus 27, minus sign, both these signs they are adjusted, it is plus over 2a, it is 2 into 2. So the answer is minus 3 plus minus square root of 9 plus 2, 1, 6 over 4, and this is minus 3 plus minus square root of 2 to 5 over 4, and this value gives us minus 3 plus minus 15 by 4. So negative values we are not interested in. So what we are left with is, it is 15 minus 3 by 4. So the answer we will get, that is equal to 3. But in this case we are calculating the values of, so negative values we will assume over here, because this is not values of k. These are not values of area, these are values of k. So when we will consider the negative sign, the answer we will get, it is minus 3 minus 15 by 4, and that is minus 18 by 4, that is equal to minus 9 by 2. So we will have two values of k. One is k is equal to 3, and second is k is equal to minus 9 by 2. On substituting these values, you will get the answer as of the area, that is 24. Next is, if A, B, C are the vertices of triangle ABC, these are the these points we are talking about, this is A, B and C, and AD is the median. We are talking about this AD is the median. So coordinates of this D, we are saying D is the midpoint. So coordinates of this point, they are 5 plus 3 by 2, comma 2 minus 2 by 2. So coordinates are 4, comma 0. We have to prove that the median divides the triangle in two triangles of equal area. So first we are calculating the area of this triangle. Next we are calculating the area of this triangle. And we will see that in both the cases, the final answer that we are obtaining, it is same. So in the first case, when we apply the formula, it is 1 by 2, 4 into minus 2 minus 0, plus 3 into 0 plus 6, plus 4 into minus 6 plus 2. On solving this equation, you will get that the total area is 3 square units. When we are talking about this triangle over here, we are talking about ADC. The answer we will have, it is 1 by 2, 4 into 0 minus 2, plus 4 into 2 plus 6, plus 5 into minus 6 plus minus 0, and it is mod over here. So on solving this, you will get, it is 1 by 2 into 6, that is equal to 3 square units. So what we get is that area of both these triangles, that is area of the triangle ABD and area of the triangle ADC. The area of both these triangles, these are equal, and this is what we have to prove. Next is, find the area of the triangle formed by joining the midpoints of the sides of the triangle whose vertices are. So these are the vertices of a triangle given to us. A is 2, 2, B is 4, 4, and C is 2, 6. We are obtaining another triangle by joining the midpoints of these three vertices. So to calculate the midpoint of A and C, we are saying it is 2 plus 2 by 2, 6 plus 2 by 2. Similarly, we can calculate the value of coordinates of this point D and coordinates of this point E. These are the midpoints, we are saying D, E and F. These are the midpoints of A, B, B, C and C, D. And we are using this formula over here, that it is 2 plus 4 by 3 by 2 and 2 plus 4 by 2. These coordinates we will obtain. So these are the three coordinates D, E and F over here. Now we have to find the area of this triangle DEF, and the formula we know it is half mod 3 into 5 minus 4 plus 3 into 4 minus 3 plus 2 into 3 minus 5, and on solving this you will get the answer as you will, when you will solve these terms, it is 1, so it is 1 by 2, 3 plus 3 minus 4, and it is mod over here, and on solving this you will get that the area is 1 square units. Now another method to remember this formula, it is, if we look at this formula over here, we are saying this is x1, 1 by 2 is there, then mod is there, then it is y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. I am just talking about how you can remember this formula. Look at these values over here. These, it is 1, 2, 3. Next it is 1, 2, 3. Next we are saying these three values, it is 1, 2. This value we are saying it is 2 over here, and this value we are saying it is 3 over here. So what we are saying is that these values, these are moving clockwise over here, that in the next we are saying over here this 2 is shifted at this point, 3 is shifted at this point, 1 is shifted at this point. You will get it is 2, 3, 1. Next 1 is shifted at this point, this 3 is shifted at this point, and 2 is shifted at this point. What we are saying is these x, y, these are fixed. The values of 1, 2, 3, how we are adjusting these values? First we are writing it is 1, 2, 3. Then we have moved them clockwise, so it becomes 1 comes over here at this point 3, 3 comes over here at this point 2, and 2 comes over here at this point 1. Similarly, this 2 comes over here, this comes over here, you will again get the same value over here. So this is just a method how to you can remember the terms, this 1, 2, 3, how these terms, these are rotated over here, you can remember in this form. Next is find the area of the quadrilateral ABCD whose vertices are given to. So the coordinates of these vertices, A is minus 4, 8, B is minus 3, 4, C is 0, minus 5, and D is 5, minus 6. So to calculate the area of this quadrilateral, we are going to do the construction, and the construction is that we have joined these points A and C. Now we have two triangles with us. One is this triangle ABC, and second is this triangle ADC. We have these two triangles. So we can calculate the area of both these triangles separately. So first of all, we are calculating the area of the triangle ABC. So it is 1 by 2 mod. Then the value, suppose we are saying this is x1, y1, x2, y2, x3, y3. So we will have the formula 1 by 2 into x1, that is minus 4, into y2 minus y3. So it is minus 4 plus 5. Next it is plus minus 3 into minus 5 minus 8 plus 0 into 8 plus 4, and we put mod over here, and the final answer we will get it is 35 by 2 square units. Similarly, when we are calculating the area of this triangle, the formula we will have it is 1 by 2 mod minus 4 into minus 5 minus 6 plus 0 into 6 minus 8 plus 5 into 8 plus 5, and it is mod over here. On solving this, you will get the value of the area as 109 by 2 square units. This is 35 by 2 square units. So we are saying the area of this portion, it is 35 by 2 square units. This is 109 by 2 square units. So the total area we will have it is sum of these two areas, and the value we will get it is 72 square units. So this is the total area of the quadrilateral ABC. Now the next question we have is Find the area of a parallelogram ABCD if three of its vertices are, this is vertex A 2, 4, B is 2, 2 plus root 3, 5, and C is 2, 6. So we have to find the area of this parallelogram. So first of all, what we have to do is we have to find the area of this triangle, because we know that the diagonal of this parallelogram will divide it in two triangles of equal area. The area of both these triangles, they will be equal. So if we are able to calculate the area of this triangle, then the area of the second triangle will be same. So double of this area will be the area of the parallelogram. So to calculate this area of the triangle, we have half. It is x1, it is 2, this is x1, y1, x2, y2, x3, y3. So it is 2 into y2 minus y3, it is 5 minus 6, plus 2 plus root 3 into 6 minus 4, plus 2 into 4 minus 5, and it is mod over here. So on solving this, you will get it is 1 by 2 into 2 root 3, that is equal to root 3 square units. So we are saying this is the area of the triangle ABC we are talking about. So the area of the parallelogram will be 2 times this area. So the area of this parallelogram, it is 2 root 3 square units. Next is, if the points A, B, C, D are the vertices of a parallelogram, then taking AB as the base, find the height of this parallelogram. So we are saying these are the coordinates A, B, C, D. These are the points given to us. We have to find the height of this parallelogram. So to find the area of this parallelogram, we are calculating the area of this triangle ABC. The area of this triangle is 1 by 2. These are the values x1, y1, x2, y2, and x3, y3. So it is half. Then it is 1 into 3 minus 2, plus 2 into 2 plus 2, and then it is plus minus 3 into minus 2 minus 3. And when we will solve this value, we will get it is 12 square units. This is area of this portion. So area of this whole parallelogram, that will be 2 into 12 is equal to 24 square units. The area of this whole parallelogram, it is 24 square units. Now we are saying, we are considering this AB as the base. We have to find the height corresponding to this base. So we have to calculate this length AB, that will be equal to 2 minus 1 square plus 3 minus minus 2 square, and the value we will get, that is equal to square root of 1 plus 25, that is equal to root 26. Now we know that the formula for the area of the parallelogram, that is base into height, and this value is equal to 24, and the value of base we have, it is root 26 into h. So h we have, it is 24 by root 26. So it is root 26, and root 26 we are multiplying and divide with this term to rationalize this. So the answer we will get, that is equal to 24 root 26 by 26, that is equal to the value of this root 26 we have to calculate, and that comes out to be 5.09, and the final answer you will get, it is 4.69. It is not necessary to calculate this value because it is not given in the question, so you can leave the answer up to this place, that it is 24 by 26 root 6 root 26. You simplify these terms, and the answer you will get, it is 12 by 3 root 26. So it is the final answer, you can write it is 12 by 13 root 26. So it is up to you that you want to calculate this or not. But if in the question it is given that you have to write the answer up to 2 decimal places, or the value of root 26 is given in the question, then you must solve these, you must perform these calculations. Now the next question we have, show that the points, these are the 3 points given to us, these are we have to prove that these 3 points are collinear. So first method we have that we will calculate the distance AB, we will calculate the distance BC, and we will calculate the distance ACA, and then we will prove that AB plus BC is equal to CA, something in this form, based upon the fact that which length is the largest length. We will show that the sum of the two is equal to third. So in place of this, we are directly using the formula that if these three are collinear points, then the area of the triangle formed by these 3 points should be 0. So the area of the triangle formed by these three, it is minus 1 into 7 minus 10 plus 5 into 10 minus 1 plus 8 into 1 minus 7. So the answer we will get, this is equal to 3 plus 45 minus 48, that is equal to 0. So we are saying if the area of these 3 points it is 0, it means these 3 points, they are collinear. Area of these 3 points means area of the triangle formed by these 3 points. It is not area of these 3 points we are talking about. We are talking about the area of the triangle formed by these 3 points. It is 0. It means these 3 points, they lie in a straight line. Next is show that the points, these 3 points are given. We have to prove that these 3 points, these are collinear. So again, we are considering a triangle whose vertices are ABC. We calculate the area of this triangle. So it is A into, this is the x coordinate, then the value we will have, it is C plus A minus A plus B. Then the next value will be plus B into A plus B minus B plus C, and plus C into B plus C minus C plus A. When you will open all these brackets, you will see that this A and A gets cancelled over here, this B and B gets cancelled over here, and this C and C gets cancelled over here. What we are left with is AC minus AB plus AB minus BC plus CB minus CA, and the final answer we will get equal to 0. So we are saying that the area of the triangle formed by these 3 vertices ABC, it is 0. It means these 3 points, they are collinear. Now in this question, we are given that the area of a triangle with vertices, these are the vertices of the triangle, and the area of this triangle, it is given to be 6 square units. We have to prove that these two equations will hold. So writing the formula for these points to calculate the area, we will get the value of area, it is 1 by 2 x into 2 minus 1 plus 1 into 1 minus y plus 2 into y minus 2, that is equal to 6 square units. The area is given. On solving these values, you will get that 1 by 2 into mod of x plus y minus 3 is equal to 6. So mod of x minus plus y minus 3 is equal to 12. You have not studied the mod function, but how you can understand this is, if suppose I am saying x plus y minus 3 is equal to minus 12, then the mod of this value will be 12. If we are saying x plus y minus 3 is 12, then the mod of this value is 12. In both the cases, the answer is this. So it means both these conditions, if they are satisfied, any one of these conditions is satisfied, then this equation will be satisfied. So from this equation, we will get x plus y, that is equal to minus 9, and from this we will get x plus y is equal to 15. So this gives us x plus y plus 9 is equal to 0. So these are the two things we have to calculate. X plus y plus 9 is equal to 0 and x plus y is equal to 15. Next we have is find the value of k for which these 3 points are collinear. If these 3 points are collinear, it means the triangle formed as by these 3 vertices, as these 3 points as the vertex, the area of that triangle should be 0. So we are saying these are the points x1, y1, x2, y2 and x3, y3. So the area of the triangle we will have, it is mod of x1, the value we have, it is k plus 1 into 2k plus 3 minus 5k. We're talking about this is k plus 1. Then we are talking about this value, it is 2k plus 3 minus 5k. Similarly, the next value we will have, it is plus 3k into 5k minus 2k plus 5k minus 1 into 2k minus 3, 2k plus 3, and this total area, this should be equal to 0. This whole area should be equal to 0. Now on solving these values, we will get that the answer we have, it is 6k square minus 15k plus 6 is equal to 0. We take 3 common, so we are left with 2k square minus 5k plus 2 is equal to 0. So by splitting the middle term, we will get minus 4k minus k plus 2 is equal to 0. So the values of k that we will get, they are 2 and 1 by 2. These calculations, these are shown over here. So we are saying the required value of k are 2 and 1 by 2. Now next we have is, if the points A, B, C, these are the 3 points given to us, and these 3 points, these are given to be collinear. Further, it is given that 2b plus c is equal to 4. We have to find the values of b and c. Now from the collinearity condition, we are saying that the area of the triangle with these 3 points at the vertices, it should be 0. So we get, using this formula for the area, why we are not putting mod over here, because it is equal to 0. So we know that the value is 0. We are not putting mod over here. So it is minus 1 into, it is the value we have, it is c minus 1 plus b into minus 1 plus 4 plus 5 into minus 4 minus c. This is equal to 0. On solving these values, we will get, simplifying these values, we will get b minus 2c is equal to 7. So this is one equation we are getting. It is b minus 2c is equal to 7. Second equation we have, it is, one is b minus 2c is equal to 7, and second we have is 2b plus c is equal to 4. On solving these two equations, from this what we get is b is equal to 7 plus 2c. So it is 14 plus 4c plus c is equal to 4. So 5c is equal to minus 10. So the value of c we have, it is minus 2. Substituting this value over here, the value of b we will get, it is 3. So the final answer we are getting is that b is equal to 3 and c is equal to minus 2. These are the two required values of b and c. Next is, if x comma y, these are the coordinates of the point R, on the line segment joining the points, these are the 2 points given to us, P is A, B and Q is B, A. Then prove that x plus y is equal to a plus b. So we are saying this is a point on the line segment. It means we are saying this is the point A, B, P. This is the point Q, that is B, A, and this is the point R that is lying over here. This is x comma y. So what we have is that these 3 points, these are collinear. If these 3 points are collinear, it means area of the triangle formed by these 3 points should be 0. So what is the formula for the area of the triangle formed by these 3 points? It is a into y minus a plus x into a minus b plus b into b minus y. We are talking about these 3 points over here. This is a, then it is x, and then it is b. When we are using this point a over here, we are writing it is y minus a. when we are using this point y over here, we are writing it is a minus b, and when we are using this point b over here, we are writing it is b minus y. So what we get is, on solving this, we are saying that this area should be equal to 0. When we solve these values, we get ay minus a square plus ax minus xb plus b square minus by should be equal to 0. So these are the terms containing y. So y we take common, we are left with a minus b. Next we have minus of a minus b into a plus b. The term we have it is minus of a square minus b square, and the last term we will have it is x common, and we will have a minus b is equal to 0. So what we get is a minus b common from all these terms, and what we are left with is y minus, or we are saying y plus x minus a plus b, this is equal to 0. So we are saying either a is equal to b or x plus y is equal to a plus b. We are saying if a is equal to b, then both these points will become same. This point will also become same. So that will lead to a trivial case. This will lead to a trivial case. So what we are left with is that x plus y is equal to a plus b, and this is what we have to